Okay, so, right, positive terminal, wire to the first light bulb. Since we're doing series, goes through the first light bulb, leaves the first light bulb, one path to the second light bulb. Come on. Come on. You have to be smarter than the, nope, that didn't get it. Stay. Come on. Ugh. There we go, for the second light bulb. Leaves the second light bulb, goes to the third light bulb. Again, just one big loop. From the third light bulb back to the negative terminal on the battery. Okay, I have the power supply set at 0. That's why the light bulbs aren't lighting up. Right, we turn on the light bulbs and we're good, right? That's the idea, right? One big loop. Uh-oh, what happened? There we go. One big loop. All right, that's series. All right, why my connections must not be very, one of my connections is not good because it keeps flashing off. There we go. All right, before we do this though, real quick, remember we talked about internal resistance, right? So I'm going to measure the voltage that I have set up on my power supply. Okay, I'm going to turn the circuit off. And when I measure the voltage in the power supply, the voltage reads 15.6 volts. All right, 15.6 volts. But when I turn the circuit on, some of that 15.6 volts is going to get used up in the internal resistance of the power supply. So now my reading should be less than 15.6 volts. And I'm getting 13.9 volts. All right, so what is that? I can't do my math. 1.7 volts of electric potential is being used internally inside of the power supply, is being wasted instead of being used in the light bulbs. Okay, so that's what we're talking about with internal resistance, right? The EMF, that EMF is the 15.6. That's the measured terminal voltage before the circuit is turned on. Right? The voltage of the battery, though, is then the 13.9 volts once the circuit is turned on. How much is actually getting out into the device, in this case, our 3 light bulb little circuit. Good? All right, so we're going to, for our sake, when you're filling in your data table, we're on a series circuit, right? Let's again measure we're going to measure the terminal voltage. And we got 13.9 volts. So on your data table, it should say 13.9 volts for series circuit battery, right? I think that's how I have it written. Right, or power supply. Voltage for the power supply in the series circuit is 13.9 volts. Okay? Oops, hitting the wrong buttons. And now I'm going to measure the voltage across each of the individual light bulbs. All right, so I put my voltmeter in parallel. Uh-oh. Come back on. Come on. There we go. I put my voltmeter in parallel with the first light. This is very frustrating. In parallel, I'm trying to like do this so you guys can see it. Parallel with the first volt. Here we go. Maybe try look at here, right? So the current's leaving the battery, going through the light, through the light bulb, and then back to the power supply, right? Back to the battery. So this one, I'm going to now put the voltmeter in parallel with. Okay. And I get a voltage of 4, jumping around a little bit. I get a voltage of 4.4 volts. 4.4 volts for the first light bulb. Okay. Moving on to the second light bulb. How much time do I have? Well, oh, I got plenty of time. 11:09. All right. Moving on to the second light bulb. I have 4.5 volts. 4.5 volts. And at the third light bulb, whoops, shucks. Come on. There we go. The third light bulb, I'm going to just make my wire longer here. The voltage of my third light bulb is 4.4 volts again. All right, so 4.4, 4.5, 4.4. Good? We all have that data? Okay, I'm going to take says yes, you're good to go. All right, next we're going to measure the current. Now, current has to go again, has to go in series. So it's going to leave the power supply over here, leave the power supply. So that's my first measurement. How much is leaving the power supply, the positive voltage, before it gets to the first light bulb. So I need to set this into, but I need to put it in series. So, right, leaves the power supply, goes into the meter, comes out of the meter, goes back to the second light bulb, or goes to the first light bulb. Why are we not lighting? Oh, I know what I did. Hold on. I have to put this in a different thing on my thing. All right. There we go. So I have a current now, the power supply current in the series, the power supply current is 0.33 amps. Okay, 0.33 amps. Okay. I'm going to go disconnect here. So now the current's going to leave the power supply, go through the first light bulb, go through my ammeter, and then continue on to the second light bulb and so on. So my current, it's going to, on your data table, see current for light bulb 1 is 3.3 amps. Excuse me, I did the same mistake I said before. 0.33 amps. 0.33 amps. Okay? Moving on. So now the current left is leaves the power supply, goes through the first light bulb, gets to the second light bulb. I'll disconnect it. After the second light bulb, it goes through the ammeter in series and then continues on to the third light bulb. And struggling here, as you can see. There we go. Nope. Come on. Come on. Okay. Again, the current is 0.33. 0.33 amps. Last one. Power supply. First and second light bulbs. Why am I having so much difficulty with this? This should not be, all right. Go to the third light bulb. So leaving the third light bulb and heading back to the power supply. I have, as you can imagine, if I do this right, yes, 0.33 amps. Good. Any questions? We have all our data. Okay. So we should be able to make some pretty simple conclusions, I think, about the series circuit, especially about current through a series circuit, right? Answer the questions above. How does the voltage across each resistor for a series circuit and a parallel circuit? We haven't done parallel. How's the current through each resistor compare in a series circuit, right? So current's pretty easy. Voltage, hopefully, we should see the relationship there too. Okay? Any questions so far? Do I have time to do a parallel? I'll try. I'll try and do parallel here too. All right, so I got to reset I need a couple more wires to do parallel. Damn it. Come on. I need one more wire. Or am I screwed up? Oh, very frustrated here, as you can tell. So I'm trying to set up my parallel circuit. There we go. Okay. See if I don't know if we'll have time to get all the measurements done. But here's the idea, right? Here's my parallel circuit. So if you see, I don't know if I'll be able to see it, show you this or not. Come on. I have the power supply. Let's turn the brightness down a little bit so there's not as much glare. This red wire here is coming out of the power supply, getting to this side of the light bulb. And at that point, there's a little junction. I can't get this. There's a little junction here, right? So it can then go through the light bulb, or it can continue down this wire. So it either goes through this light bulb and lights the bulb, or continues down this wire until it gets to the next light bulb. Right? Continue down that wire until it gets to night light. There again, there's another junction. So it can go through the light bulb or continue down this wire to the last light bulb. Okay. So keeps popping off here. Keeps coming disconnected. But this is it's set up in parallel. I am truly struggling here, guys, truly struggling to set this up. I don't know at this point if it's even worth trying to do it, because there's only, what, 5 minutes left in class. All right, but that's the mother jumper. Okay, the last thing, since we're not going to make our measurements, we'll make our measurements tomorrow. I do want to show you this about parallel circuits, though. Because there are various paths with a parallel circuit, the electricity is coming out of the power supply through this wire, getting to this first light bulb, and that's either going through the light bulb or continuing on. With parallel circuits, if I disconnect a light bulb, turn that one off, the current just continues on the rest of the path. So the other remaining light bulbs stay lit, right? I turn this one back on, right? I turn off the middle one, I unscrew the middle one. The other two stay lit because there's variety of paths for the electricity to flow through, and therefore the other things stay on, right? So that's how our homes are all set up in parallel, because if you could imagine, if everything was in series, since there's only one path, if one thing gets turned off, the whole thing shuts down because the current doesn't move anymore, right? It's got to that first one, it's shut off, it's done, and everything gets shut down. But in parallel, if one thing gets shut off, right? One thing gets shut off, it still has other paths to follow to get to the other devices. And the other devices still can stay on. So our homes are all set up in parallel because you can have one device on and other devices off, and the things work, right? If our homes were set up in series, everything would have to be on all the time to use electricity. All right, guys. So we will finish this tomorrow. I'll have the circuit all set up. We can just jump right in. And we'll finish the data table and writing this stuff up, answering a couple of questions tomorrow. All right.